Hello and welcome folks, we're back with another video. So in this video we're going to talk a little bit about my DIY CNC machine, hence why I have my CNC's spindle here and a little box of Endmills. So those of you who have been following my channel for a while will know that last year I basically made an entire CNC machine from scratch. You can see I'll put a link in the description, maybe somewhere you can click, where you can see a whole playlist for all the videos I have of the step-by-step process of making that and the final results. So it hasn't turned out to be a super useful tool for a lot of different reasons. It was a great learning experience to put it all together, but there were quite a few problems with it that I want to address, because it's kind of annoying me that it's sitting out in my workshop and doesn't really get a hell of a lot of use because it's not super useful. So the spindle here not being attached to it is a bit of a clue as to how much use it's getting, because this isn't even attached to it currently. More recently, the most recent usage it got, I should say, is at the Dublin Maker Festival last summer. I had it running as a demo piece, and I had made a special pen adapter for it, and it was pen plotting out business cards for me. So that's the most use it's gotten in a while. And there was a couple of reasons why it sort of didn't end up getting a lot of usage. I had gotten some feedback on it, and I actually decided that I wanted to address some of the points, because I think there's one really simple thing which I want to talk about in this video specifically that might make a huge difference. So we're going to try that, and hence why my spindle and some end mills are in front of me. So I'm going to go into a little bit of detail here about the end mills that you use, which are the little cutting tools, and why I think that might make a bit of a difference. So that's what we're going to try in this video. Okay, so this is the spindle. Spindle is quite simple. It's a motor that has pretty high speed, 20,000 RPM on this guy. And mounted to the end of it is a little adapter guy which holds a collet. So this is an ER11 collet. It's just basically the size of the collet. So you unscrew this little nut and the little collet opens up, and then when you tighten it down, that'll squeeze evenly, holding the end mill concentrically. So when I was building the machine, I bought this little set of the cheapest little end mills that I could find on Amazon, literally not knowing at all what I was doing. So these are the little guys that come, these little blue fellas, and these are all 1/8 inch shanks, which is about 3.1 and change millimeters, and they are the right size to fit into this ER11 collet. So you open it up, it's just loose enough for that to fit in, and then you can tighten it down and it'll clamp down with pretty good holding force there. So that's how you mount your end mills into the collet. So really where I want to draw your attention to is the profile on the teeth of these end mills. So they're all the same, they're slightly different diameters, but they're all the same cutting geometry basically. So if we zoom in a bit, it might be easier to see if I can get this to focus, but basically there's our geometry that we have. So you see what they call on the front of this is their sort of corn shaped end mills, and they've got this sort of real rough pattern of all these like little individual little teeth that kind of looks like a little diamond pattern. So what I was trying to do with my CNC machine is I was trying to cut wood with it basically. And these little guys, they're not really made for cutting wood, funnily enough. And so the machine had a lot of trouble with that. What these are kind of more designed for is things like PCB engraving. So you've got like these tiny little dudes here, and these are the perfect kind of size and the perfect type of bit that could basically carve away some copper traces and a little bit of fiberglass on a board so that you could make milled PCBs, which kind of makes a lot of sense. That these have a very small little tooth on them. They're quite fine. It's kind of almost reminded you of something like a little grinding tool that you put into a Dremel. So it kind of makes sense that they'd be, able to cut through or kind of engrave into hard materials, or cut through quite brittle materials like something like fiberglass in a PCB. That's my theory anyway. That's what I think was going on really with why this wasn't working very well for cutting wood. So they couldn't, these little tiny chips, they can't really bite deeply into the wood, and also they weren't really able to clear any swarf that they were creating, so you didn't really get this like chip clearance. Wasn't working very well. So kind of was causing a lot of chatter in the machine, and it wasn't really working too well. So that's just a theory I have based on some feedback I got from some people and some kind of ideas I've picked up from watching a lot of different machining and milling stuff on YouTube. So with that in mind anyway, I bought some new Endmills. So these are the same brand, but they're just a slightly different profile. They're the same 1/8" shanks, but these are all the same size as it happens. And I can show you the difference. These are basically, they're flat nose Endmills, so they've got just this flat end on them. But what's important is, if I zoom in again, they've got sort of, if I can focus, they have these sort of two flutes basically. So focus is difficult. Come on, let's get it. Ooh, almost. There we go. Come on. Might be as good as we can get, but basically they have two sort of radial flutes that run the entire length. They're quite sharp and they're relatively deep as well, so there's a couple of millimeters there of depth in each of the flutes. So the theory is that this little guy should, oh that's a better, there we go, that's a better focus. This little guy should be able to cut into the wood quite deeply and should effectively be able to clear the chips away from it as it moves. So that's a theory anyway that I have. So I'm going to try it. I'm going to reinstall the spindle onto the CNC machine, take off the pen mount, and I'm pretty much going to try this guy out. And that's really it. I don't really have a huge amount else I want to try. There is one other thing. So while I was thinking about this and thinking about these different Endmills, I actually realized that I had yet another thing that might be helpful. So I bought this little box of mini little router bits ages ago, and this happened to be for a project I was doing. Well, not a project I was doing. I had bought this little adapter kit where you can put a little Dremel into it, and it turns a Dremel into sort of a little mini palm router thing. And I bought these tiny little miniature router bits. So it's a full set of all these different kinds of router bits that all happen to have an 1/8" shank. So that's about perfect for going into my ER11 collet here. So that will hold that just about fine, which is cool. So yeah, I can try that out and see if any of these guys will help at all. It might not help at all, but just interesting to see. And also if they do work, then I've got a whole selection of different tools with different profiles that I might be able to use for other things, which is kind of cool. So that's something I can try out as well. So yeah, that's the next thing. I'm gonna set up my machine. I'm gonna check, see what happens with all these little dudes, and yeah, we'll see what results we can get out of it. One thing that I do want to do first, which actually I think I'll jump into next, is I haven't used Fusion 360's cam yet. So back when I was working on all this CNC stuff, I was mostly using FreeCAD, and I was using FreeCAD's cam workbench to be able to do the cam so that I could plot out my tool paths and everything for the CNC machine. Now I'm using Fusion 360 for everything, and I've actually never used the cam workbench there. So I'm going to take a look at that. I'm going to mess around with it, and if I figure out how it works, I'm going to show you guys. So yeah, we'll give a little walkthrough about what I'm doing, how I'm setting up the cam for it, and then we'll go from there and we'll test out our different Endmills and stuff, and yeah, we'll get some results hopefully. Maybe the machine might actually be a little less useless than I thought it was. It turns out if it is still a bit useless, I do still have some plans of different things I want to do to make it better. But yeah, this is the first starting point. So we're going to go and look at some cam, and then we're going to go test some stuff out. Hope you guys will stay around to join me. Okay, so let's have a look at some cam here. So I'm in Fusion 360, and I've created my model here, which is
really simple. It's about as basic as I can make it, which is the idea for this whole test. Is I wanted to make a really simple model with a really simple thing that I'm going to cut out, so that I can eliminate as many variables as possible with the test. Just a simple cut, so I can try and isolate what the Endmills are doing, what the effect they have, as opposed to, you know, any sort of weird toolpath stuff or, you know, depth of cuts, all that kind of stuff. So what I've got here is this really basic model. It's effectively, what I did was I created just a solid model which represents the stock that I'm using. In this case, I have a bunch of sheets of 6mm thick plywood that is A4 sized. So that's what I've got here. I've got my little rectangle of stock, and all I've done in terms of the features that we're going to want to cut is I've added this tiny little round pocket here, which is 3mm deep. So the other thing I noticed before when cutting through this material was that the 6mm depth of cut seemed to be maybe a little bit aggressive. At least it was with the old kind of corn shaped end mills that I showed you guys earlier. So I'm going with just a short kind of 3mm depth of cut. Now that could prove to still be too aggressive, so maybe, I mean, you need to go less, but effectively we've got this fairly small amount of, you know, material that we're going to be removing. This is, I think, 30mm in diameter, so it's not huge. And basically what we want to do is we want to put this piece of stock into our CNC machine. We want to click the button and we want it to cut out this little pocket for us. So to tell the machine how to do that, we need to use the CAM tools that are built into Fusion 360. So if you kind of understand a little bit about 3D printing, maybe you understand the idea of a slicer. So people who are familiar with 3D printing will know that just because you can 3D model it doesn't mean you can 3D print it. So you can design in CAD or in Blender or in all sorts of different 3D modeling softwares, basically literally anything, but you can't just make anything. You know, your 3D printer can't just start printing in midair, that kind of thing. And your CNC machine can't just, you know, get in at the backside of any material. There are limits to what these machines could physically do. So in 3D printing, we have a tool called a slicer, which effectively is the CAM tool that's very specific to an FDM 3D printer, for example. So in our case, we're just saying CAM, you know, generically, but effectively what CAM is going to do for us in this case is it's going to take our 3D model and it's going to build a set of instructions, which when fed into our machine, in this case, my DIY CNC machine, will make the machine do what we want. And this is the exact same as how a slicer generates your G code, which is what tells your 3D printer how to make the parts you want to make. So to get into this workbench in Fusion 360, you go up here to the top left where it says design, and we're going to select manufacture instead of design. So this dumps us into here, and you can basically see the guts of what is needed already. So I already prepared this, but I'll basically go through what I did and explain what this means basically. So for this case, we're basically just working pretty much in 2D. There's nothing super complicated here, and 2D with depth. So this is difference between this. You can have 2D stuff and you can have 3D stuff up here. The difference is basically with 2D stuff, we're just working in the one plane. We're not doing anything that has angles on that plane. So if we had angles or curves, tapers, that kind of thing, then we'd be using the 3D tools, but we're not, we're using 2D. So although there is a Z dimension to it, we're always just machining in one plane. We're never, we're not making like angles, like cut like that or anything like that. We're no angled faces or anything like that. So I can go up here. This is about the simplest method you can use, which is the adaptive clearing path. So it's like it says there, it's a roughing operation. It's not meant to be, you know, fine details. It's meant to just be an efficient way of clearing away basically lots of material. So we're going to use that path, which is about the simplest one you can use. So if we click on this, it'll bring us up with a little dialogue. I'm not going to click it because I've already done it. But effectively, the guts of what the dialogue asks you to do is it asks you to select a geometry that you want to adaptively clear. So some tools make this a lot easier than others. In FreeCAD, which is what I've used before, it's a little bit cumbersome. In this, it's so easy. This geometry was ready to be highlighted. I moused over it, clicked it, done. Effectively, almost as simple as that. The only other thing that it asks you to do, which is a little bit more involved, if you've not done it before, there's a little bit to read up on and stuff, but in any case, it's not too difficult. And that's basically select your tool. So I could show you here, the tool we have selected is here, and it's basically a 3mm flat end mill, which is, if you remember from earlier, that's basically what the new mills that I want to try out are. So if we click on this, it opens up this wizard. So when you're going through the whole setup process, when you've selected your adaptive clearing, you've selected the geometry, you'll be asked to select the tool that you want to use, and you'll get given this basically this dialog. So there's a whole bunch of presets in here. So I've gone and selected metric milling tools, and you can see there's a whole load of different ones that are already all pre-programmed in here. So I just scrolled until I found what I wanted, which was this 3mm flat end mill. So I can go back here and I have that selected. The other thing then that you have to select is basically the cutting defaults down here. So if you watch a bit of YouTube milling stuff, you'll have heard of your feeds and speeds, and this is effectively what this all means. So you've got your spindle speed, and then you've got your feed rates. So you've got your cutting feed rates, lead in and lead out feed rates, and that kind of stuff. And I'm not going to get into details about this, but effectively this is how you define how quickly the machine moves around while it's cutting and how quickly the spindle actually spins. So I have this selected, which is the default preset. This probably isn't going to work, but I have it selected just because it'll give me some values and then I can mess around with it. I am going to mess around a little bit kind of by feel with this, because I'm not entirely certain what feeds and speeds I want to use. So what I will probably do is I'll select a default, I'll generate my code for it, and then I'll run it on the machine without the stock, and I'll just observe how the machine's moving, and then I'll probably tweak it from there. So I'll either come back here and mess around with the settings, or I'll just tweak the G code directly. That's not too complicated to do, and then I can kind of iterate on that to get the feeds and speeds that I think I want, and I'll plan on testing a few different ones anyway. So yeah, that's pretty much it then. You can select, and that'll do it. And that gives me this whole thing. So I've got my adaptive toolpath set up, I have my tools selected, and I've got the pocket that I want to mill out selected as well. And that's pretty much as complicated as it gets for the setup on this, which is remarkable. I'm really impressed with how easy this was to set up compared to what I had done in FreeCAD before. Yeah, it's like, yeah, night and day difference. Now, maybe people who know a lot more about this than me will tell me that there's better things in here or whatever. I don't know. Maybe there's probably better tools as well for professionals, but I think for a hobbyist, this is about as easy as it can get, which is fantastic. So the last kind of cool thing that you can do here as well is you can simulate what this is actually going to do. So we see here we have all these kind of spirals and stuff, and it can be a little bit hard to see what's actually going to happen. So if I go into here to my setup and I click the simulate button, this is basically telling me from the start here, showing me how my tool is going to be removed and how my tool is going to move and how it's going to remove the material. So you see it starts up here, it's going to move down this line, it's going to start spinning around in a tight kind of spiral pattern until it gets to the depth at the bottom, and then it's going to fan out and remove material at a depth of 3mm until it gets out to the edge here, and then it's going to lift back up again. So if I click the play button, there we go. So we're down to the bottom, and now we're spinning around until we get out to our final depth or final width, and then up to the top. And you can slow that down so you can really watch it. And it's kind of cool when you do that and you zoom in, you can see how the cutter is engaging with the material. So you can see how much of the cutter is engaging with the material, which is pretty cool. So yeah, that's about it really in terms of your generating your cam profile basically. So the next thing you've done now is once you've set all this up, you need to export all this to to G code effectively for my machine. So if you hadn't watched my earlier videos, my machine is using an operating system called GRBL, which is basically, it's an Arduino based thing that runs pretty simple flavor of G code to do all of its movements. And it just so happens that this the Fusion 360 supports it as an output where you can target your post processor to point to GRBL. So if you go into, I think it's up here, yeah, post processing, you can click here, and it basically gives you this little window where you can select what it is. So if you go to post here, you can choose from a library, and effectively when you choose from this library, it has loads of different machines and types of flavors of G code you can select. GRBL is an option, so you can just use that preset, and then this will generate a file for you, which is all your G code. And that's, again, pretty damn simple. So if we have a look at what that looks like, got it here. This is our G code file. So yeah, it's pretty standard stuff. If you've seen a 3D printed G code file, it doesn't look a hell of a lot different. We've got our X, Y, Z axis movements. We have, spindle speed. We've got feed rates, all that sort of stuff. And yeah, that's really about it. I think this is about, just over 1,000 lines long. So if you're using some free software, you may need to chunk this up into different files. But I think the G code sender I'm using, free G code sender, I think it's Ultimate CNC, has an unlimited number of lines it can send. I think I must check that. Can't really remember. So we'll check that and see. But yeah, that's basically it. So I'm pretty happy with that. That was really painless to set up. And now, next step, I can go and take that G code, load it onto the machine, and see what happens. So I'll see you guys at the workshop.
So this is probably a pretty good time to talk about probably the single biggest issue with this machine. So now that I've got the motor mounted back on, I can show you. And it's basically its rigidity. So that's the problem with all these kind of hobby CNC machines, especially aggravated by one that's largely 3D printed. So you can see here, the spindle will hold the little end mill here. All of the force that the machine generates is going through the end mill. So essentially you've got forces here, in the X and Y, and also in the Z axis. And as I put some force on the end of the collet nut here, you'll be able to see the amount of flex that this little machine has. So that flex is really the biggest killer in this machine. So especially if you load that axially, you'll see there's a huge amount of movement there. So if you had a really good, really solid CNC machine, you should be able to grab that spindle and try and force it as much as you can, and the whole machine shouldn't really move. Unfortunately, in this case, I just don't have the rigidity. So what I was noticing big time with those corn-shaped cutters was the machine's forcing to get the cutter to move through the material, and that was causing this thing to move a lot, because for the amount of force it was putting on, it didn't have the rigidity to hold up to it, and so the whole machine was bending, which obviously means that you're not going to cut anything accurately. So I'm not fixing that rigidity problem today. I do have some things I want to do that might be able to fix that. But what I am going to do is, hopefully with that cutter, we'll get less force on this as we try and cut through the material. If it cuts through the material smoother, less force on this, less deflection, overall better experience. Again, only a theory. We'll see what happens in practice. Also you have to think, force is relative. If I was to try and use this to cut through steel, it definitely isn't rigid enough. Might just about be rigid enough to cut through wood. Probably also not rigid enough to cut through aluminium. But if I could get it to at least cut through some wood, well, that would be a good step, and hopefully that the experiment we're going to do now will tell us a yes or no on that. Okay, we're set up ready for a test. So I've got the button ready. I'm going to click it. I've set it up so that the end mill is just about over the surface of the work. So I should click the button, it should lift up, should move to where it needs to start, should start spinning, and move down into the work. I noticed the feed rate was a little bit fast, so I'm going to put the feed rate right down, which I can manually edit in my control software here. So we'll see what happens. I might have to hit the e-stop button very quickly, but let's see what happens. Click the button now. Alright, there's a problem. Alright, take two. I think it was a problem with how much Z I had, so I added an extra piece of board on top here so that we give ourselves a little bit more Z for the machine to play with. So click the button again, and let's see what happens. Well, that's doing a pretty decent job, it seems. Very low feed rate, and it seems to be doing pretty well. That sounds crunchy. Okay, so here's the results from that test. So might not come across super well on camera, but yeah, I think it's actually pretty clear to see. This is not a terribly round hole, so you can see where, especially on the inside edge in here, we got a lot of chatter, and that's just that rigidity thing. So now that sounded and ran a lot better than it did with those like corn-shaped end mills. So I'm pretty happy with that, but there's more to do here. One thing I've not actually tried before, which I'm going to try next, is I'm just going to try stacking up more wood so that there's less tools stick out on the Z-axis. I'm going to try to bring that Z-axis up as high as I can, and just see, does that help with the rigidity so there's less leverage from the tip of the end mill. So we're going to give that a try and see what happens. Okay, this is a test with everything choked up. The workpiece moved a little bit closer up, and the end mill choked up into the spindle a bit more. So let's see if that makes any difference to all that chatter. Don't know if it will, but let's see.
So a little bit of a spoiler, this didn't really make that much of a difference. And honestly, like, I knew it would make a bit of a difference, and it did. To be fair, there was a good bit less chatter, but the quality of the cut really wasn't improved hugely. I think kind of what I've hit here is the limit of what this can do in terms of depth of cut. So I was making a 3mm depth of cut, and it was kind of okay with this setup, but it wasn't really like nothing I tried a few different things, and nothing really made it much better. So I think that's kind of where the limit came in. The biggest surprise was trying out these different kinds of bits. So up to now I've been using these sort of blue carbide end mills, which might not be the ideal tools for this anyway, but I then swapped in some super cheap little mini wood router bits with an 8-inch shank that I had, and they turned out to be the real stars, and they ended up giving me the best cut. So I suppose I should maybe have expected that, because they were wood router bits made to cut wood. But anyway, that was a little bit of a surprise to me, and yeah, that's kind of what ended up giving me the best results.
Okay, so I think that's a wrap for these tests. That was my last test there with this guy, the big chunky wood router bit, and seems to have given me the best results. So that's promising. There's more tweaking to do. The hole's not perfectly round, which I'm noticing now. Think probably to do with, there's also, I haven't really tensioned the belts in this. I literally spun the machine up after about 6 or 8 months of it doing nothing, so could do a little bit of tuning up, but yeah, I mean, it worked. so that's good. Kind of surprised. I didn't think that these little bits would be the real star, but yeah, it seems that those guys, which are made to cut wood, have given me the best results here. So that's cool. I'm going to leave this video here, I think. I've done a lot of testing, and the video is going to be getting pretty long at this stage. So I'm going to leave it here, but make sure you subscribe and stay tuned for more CNC messing, because I definitely want to do more of this. now that I know that I've got a machine that I can count on a bit better. So I'll see you guys in the next one.